Hello, I wanted to make a video to go over some parts of the midterm skills review. So I'm looking at question 1, and for this question, it looks like a word problem, but the only thing they're asking us to do right here is to evaluate the function at 30. So when v equals 30, what is the function equal to? So I'd like to hop over to Paint. And what this notation means, the little variable here inside the parentheses, this is our input variable, or our independent variable. So if you imagine we have a function rule, and in this side goes a v, and out this side comes some number. I'll call it f of v, or the function evaluated at v. So what they want me to do is they want me to stuff in v equals 30, and they want me to figure out what happens, what's the value when v equals 30. So one way of rewriting this is f of v, that's my input, equals, now wherever I see v, just going to put it in yellow for a moment. Wherever I see v, that's where I have to put my 30. They want me to evaluate the function when v equals 30. So I'm going to go back through here, and wherever I saw a v, I'm going to replace it with 30, and then I'll get out my calculator or pencil and paper and crunch out the numbers. So 0.25 times v squared, so that's looking at a 30 squared. And now we can compute those numbers. We can do it with a calculator or by pencil and paper. And we get the answer of 255. So in went 30 and out came 255. Input and output. Now, the next part of the problem is a little bit different. Here they want me to substitute 2v. So let's take a look at how that would change. So now instead of v as my input, the input is going to be 2v. So wherever I saw a v before, I'm going to replace that with 2v. You know, it's like if you had a pineapple, or you had a 100 or whatever is your input argument, you're just going to go through and copy paste and put it in wherever you originally saw the v. So let's crank through these numbers. So the 2v is just sitting there in front, plus 0.25, and I'm working down the page to keep everything organized. Now, 2v squared, so that's going to be 2v times 2v. That gives me a 4v squared. Let's keep going. 2v is sitting out in front. Now I've got 0.25 times 4, so that's going to give me 1v squared, and that's my final answer. Looking at question number 3, domain and range. So the domain is the set of input values we can put into the function, and the range is the set of output values. I really like to graph these functions. So I'm going to go here to Desmos and click on the graphing calculator, and our function is going to be 9 minus u squared. And it's a little hard to see the calculator as it is. Oops. So I've just resized my window so you can see what I'm up to. There is a little wrench icon here in the upper right-hand corner, and if you click on that, you can set a different viewing window. So I'm going to set my viewing window, -4, whatever is fine. But there's something up here that I can't see, and I want to see that. So I'm going to set this to 10. Okay, that looks much better. I'll click back on the graph. So in terms of my input values, I can put anything in here. I can square it. Fine. That's my domain, and that was correct. But in terms of the output, I'm getting all these negative y values. I get y = 0, and I keep getting more y values up into a maximum point here of y = 9. So for that reason, the range would be all real numbers less than or equal to 9. 9 is the maximum value that we're going to get. Okay, and one last question before we wrap up this segment of the review. Let's take a look at this one. So this one says find the value of tangent theta given that the secant of theta is 1.3575. Okay, so let's head over here. I'll make us some space. Okay, so here I've written the problem, and we have a couple of ways to solve this. So I'll solve it in 2 different ways. You decide which way you like the best. So the first method would be to use inverse trig functions. And so if we want to find theta, we need to do arc sine, or the inverse sine. Sorry, the arc secant on both sides. So when we do the arc secant of secant, we just get theta. Those are inverse operations, so we get theta. And on the right-hand side, we need to type this into technology to figure out what the answer would be. So I came over here to Wolfram Alpha. There's the website. And I'm going to type in arc secant of 1.3575 and hit enter. And I'm going to scroll down a little bit. So it gave me a result in radians, and then it also gave me a result in degrees. So 42.55 if you want to work in degrees. I'll write that down. And then step 2, now that we have the angle for theta, is we need to take tangent of that. And so, arc secant of 1.3575 is this angle. We could get really tricky and just put tangent around all of this, because that will preserve all the digits of precision. And we get a value 0.9180, okay, etc. We got a lot of decimals in there. Let's see what my math lab wants in terms of decimals. It wants 5 decimal places. So we would go 9180.5, depending on how you round. Now, the other way to proceed with this would be to look at a right triangle. So I'm going to draw a right triangle here. And I'm going to label one angle theta. Now notice that secant of theta is the same as 1 over cosine. We know that cosine is adjacent over hypotenuse. And if we wanted to write secant, it would be hypotenuse over adjacent. So I know the value of secant theta. It's 1.35, etc. So let's call our hypotenuse 1.35 0.575, and we can call the adjacent side to theta 1. And so indeed, we've got a triangle where the secant of theta is what they gave us. Our goal is to find tangent of theta. So we need to find this missing side here. I'll call it side B. And so once we have that, we can then do the ratio, and that's our tangent function. So we would need the Pythagorean theorem, which says that 1 squared plus b squared equals 1.3575 squared. Solving for b, we're going to do the square root of 1.3575 squared minus 1. So we'll need to head into technology to figure that out. And this is telling us that that side would be 0.918045. So let's write that down. And lastly, I'll just make a little space here for step 2. So there was step 1, which was pretty lengthy. In step 2, I'll just write down here, we just need to do the tangent of theta, which is pretty much done at this point. Tangent of theta is opposite over adjacent. And in this case, our opposite is 0.918045 over 1. So tangent of theta, I forgot the tangent of theta over here. I'll just write that down. We get the same answer either way.